Hello, my name is Mikhail, and here is Konstantin, and we are going to speak about the developments that run successfully in Avito company. We use logical replication as one of the approaches to structure data inside a complex system and transfer them between different nodes, regroup them, materialize them, scale them, and so on. And we have made a lot of presentations on these topics, and here you can see links to the major part of them. I spoke a lot about it, and Konstantin spoke a lot about it, and Avito, from the very beginning of its development, has employed a lot of these features, and we have reported on that. The idea of the present speech is to show that now in Postgres 10 there are certain features connected with embedded logical replication, and our idea was to take this new 10th release and have everything that we used to do, trigger replication, GQ, and Skype version, and relay it to Postgres 10. And it turned out that this very interesting activity demands deep understanding of processes and how replication in progress runs, and logical replication embedded into Postgres 10 is based on WAL, and the replication that has existed forever has a component that decodes binary stream added, and it turns it into something more affordable for replication. I understand that you can't hear me well, but it's really not very convenient. The audience is really large, but my presentation is very particular. So what is the point? We have a new component added to binary stream, allowing to extract logically readable changes, and then they are logically processed. It turns out that it is easy to come up with this native system. You can subscribe one or several persons, and it will all be consumed, and it will turn up logical standbys and so on. But having a multi-channel experience of logical replication in Avito, because we deliver distributed reference books and come up with scaling and so on and so forth. So we know that the most interesting thing starts when there are failures. And what is interesting about failures is when all this stuff runs, all links are asynchronous, and there is a certain temporal lag between input and output, and at a failure it will always happen that there will not be totally consistent nodes, and you will have to understand whether from one node to another, stream is in the past or in the future. So that is what I'm going to focus in my presentation. In terms of how it all works for logical replication, and as for how it works with Skype tools with that elephant, that is something that we have said many times, and all the logical changes are stored in an ordinary table there, and all the manipulations happen at logical level. And how can it be done when everything is connected with the binary log and upgrading to PostgreSQL 10, Avito now is thinking how to do it all, and now the leading expert of Avito will give us more detail about it all. And as for me, you would be able to ask me how we got at that, and I can also give you some particularities in terms of how it all was implemented in Oracle and why we started migrating to PostgreSQL 10. Hello everyone, again my name is Konstantin, and we have got to the essence part of our presentation, and myself, Mikhail Tyurin and started doing that when PostgreSQL 10 was in alpha version. And now I'm going to show you our main cases. We will have 3 examples of failures and how to come up with one logical subscriber from another, then undo tool and redo tool. How did it all happen as a rule? There is a failure. That is why, as a rule, we usually have 2. So we have the main source and 2 logical consumers, Replica 1 and Replica 2 from Replica. Then there is a failure, and after that we can switch the traffic to Replica 1, and we have to come up with a new Replica for redundancy. And sometimes it is hard to read your data from the main cluster because it is overloaded, or maybe there are not such data there per se. Maybe they turn up during replication, so we come up with a replica from another subscriber. So we have to rewrite the old replica, and then we have to wait till the new subscriber, active subscriber, will get this position, and then we switch on dump and launch replication. Now let us talk about how to do it in PostgreSQL 10. First we need to have our terminology in sync, and that all the cases that I'm going to refer to are around logical replication consumption. So we have a logical slot, the source of logical replication. Here it is, a replication slot, and we have a certain LSN. That is a position and wall that consumes that slot, and then it relays the table with logical application to our logical consumer. And to understand the current position and status and consumption of slot, we need to go to PG replication slot. And as for the subscriber, it has a somewhat different structure. There is replication origin there, and it is an array of memory that is composed of a name that has LSN of the last logically applied data stored there, and it is stored in memory, not in table. It is not transactionable, and it is really critical, and we will go back to it further on because there are certain complications because of it. And as for what we do, we first create our slot with the first command And then we see that we have this newly created slot, Replica 2. Afterwards, we need to switch off our currently active Replica 1, and that is really important because we're going to do PG dump from active Replica, and as I had already said, PG origin is not transactional. So if we do not stop this transaction, at the moment when we do dump, we will not know the position of the logical replication process. Therefore, we need to store the consumption of logical replication for active replica. And apart from that, we need to remember remote LSN, this number that will correspond to a new PG dump for our new subscriber. Afterwards, we start running PG dump, and another important thing here is that we should switch off no subscription, because we should not dump subscriptions. As when we do PG dump, there will not be a link after tables recovery. There will be just inactive subscription, and we would be able to get a list of tables only when we switch on the play, and when for that we will need to call refresh function, and all this data set that happened at that time will just disappear. That's why this moment is really critical. Afterwards we can switch on replication, because we have a snapshot and we remember the position of replication, and at our active subscriber that has not crashed, we switch on replication, and we can see that at replication slot there is traffic theoretically running, and now two slots, two replicas are different, and the xmin catalog is also different. That is an identifier of minimum transaction that is needed for logical decoder to have a look at the PG catalog, and for vacuum not to clear up the entries in PD catalog. And we can see that first replication slots were identical both for standby and two logical consumers, and now that we have launched dump and switched on our active replica, we can see that there are certain changes going on it, and the difficult slot is lagging behind, and the restart LSN for active subscriber is more than for inactive. As for what we do afterwards, as I have said, in the dump we did not copy subscriptions. Therefore, now we need to create a subscription for the new subscriber restored from PG dump, and we indicate important parameters. We need to indicate that it should be switched off, and we don't need to create a slot because we have done it already, and we should not copy data. Therefore, we have this subscription, and then the lower replica one, that is the LSN that we memorized when we stopped logical replication for active subscription. And afterwards we need to move our LSN for newly created subscription for the LSN that we memorized. And we receive the name for it from OID of subscriber, and replication origin advance is not dumped either, and therefore when we restore this base from PG dump, it was vacant. So after we did it all, we check the status to see that everything went on successfully at this subscriber, and afterwards we launch replication. And here we look at the position in the slot, the meet, so the data runs smoothly, and in the future we would be able to see that everything is identical for both replicas. One comment, Konstantin. So that was a detailed algorithm schema that can be described in the following way so that it can become clearer. Our task was as follows. We had two consumers. then one consumer crashes and we would like to come up with yet another one. And to do that, we do not dump the source, but we dump the consumer that is left and subscribe it NU to the source. Mikhail is asking whether everybody understands what is going on, whether it is clear to all of you. Regrettably, when the speaker does not use the mic, the situation is worse. So what we're talking about here is that all the scripts shown enable to understand the positions in the binary stream in relation to which we need to move ahead. So we had a source that is preserved, and we needed to understand up to which LSN it was played. That is why we made it on pause. Then we store all the needed LSN, and then we need to understand what position we need to start consuming the newly created slot from. That is the magic. The second case. Undo. Think of the following situation in your infrastructure. You have a source provider. Provider has a standby. At the source, there is also a logical replica. And then there is a crash on provider side. And as we have synchronized replication, and on different reasons, provider standby can be a little bit in the past in comparison to logical replica, and this replica turns out to be in an accessible and reachable future. And for that, we developed undo lock Avito. That is a trigger that writes actions reverse to those that are taking place. So in case of a crash, we promote standby, and then we have a look at the position of the standby and apply this undo lock towards that position. So we rewind our logical consumer to the past. And let us have a look at how it is done in Postgres 10. Here is a link to GitHub, and all the scripts that I'm showing can be seen there, and implementation of undo trigger for Postgres 10 and function of undo implementation. So let us have a more detailed look at undo lock. It is a table somewhat similar to audit lock. So for insert, it has a delete for update, reverse of update, for delete, insert. And there is also identity key, a field that is unique and that can be primary key as well. And we had ticks for logist and LSN for logical application. And using them, we would understand what actions we need to rewind back. And now let us look at implementation of this scenario. After a crash at the provider side, after we promote the standby, we cannot send traffic to standby which is promoted, because if you do so, you don't have a slot, and actually it is impossible to create a logical slot at standby. That's why all these changes will never get to your new subscriber that is active. And another thing is that LSN can get crossed, and undo will rewind that. So we do not send traffic after promoting standby. First we create a slot, we need to remember that. And before promoting, we need to memorize LSN position, because this position is needed for us to understand what place we need to rewind our logical consumer to. And afterwards we can have a look at what rights turned out to be in unreachable future in our logical consumer.
So we'll look at the current LSN subscriber just for you to see that it is in future in the origin. And next we'll launch the undo function, the one we saw on the standby for that. So we'll launch it, and what we get is we roll back the logical consumer in the past. We use all the reverse function, and then we switch on the replication. Well, looks like it's done, but there's a couple of nuances. When our undo trigger runs the undo lock change, the transaction is not committed yet, so the origin cannot be seen. So the undo log are marked with the previous LSN, and you can see this in detail on this slide. There's the master lesson 5, 8, 12, 15, and the standby is somewhat lagging behind. It's 5 and 8, and the action which is compliant with lesson 8 is recorded as lesson 5. So on the replica you should apply undo log starting from all the changes which are similar or more than 8. Another interesting point. There are cases when the logical consumer has lots of sources. For instance, the tables are exported from various sources and collected on one logical consumer. In this case, you have to, or maybe there are more than one table. You need to mark the undo lock as concrete events from various sources. So to do this marking, and here I would like to thank Stas Kovic from Postgres Pro. You can look at the PGStat subscription that you can use PG backend, and you can get stats of the subscription. You cannot learn who's using our application on the data source. So you need to go all this long way. You have to have a special list where you need to record all the subscriptions and the publication. Next, we would recommend you to call subscriptions by the name of the source so that you can use undo easier. So much for undo. The third case, we have not told about it before. So the previous case shows that the logistics of the replication, there was not enough logical information for the replication. So we had to add it on top. In the system which we used, all the connections between the subscribers and the sources were always identified at the logical level, at the script level, and the topology level in Postgres tables. Whereas here, some of the data about the subscriptions have to be taken from the technical information, which sometimes is not even dumped. Another part shows that when you create the replication topology, you need to restore the information to be able to see who is connected to whom. So that is my comment. So this brings us to another interesting mechanism, redo. We have never told it to you before. There's a short mechanism at Londist, but so first in general, what is this about? So we have a source of logical replication. It says a logical consumer, and the logical consumer has a standby. And let this consumer, the logical consumer, crashes. In this case, standby has not received all the updates that have been already played on the logical consumer. So then we promote the standby of the subscriber, and next we need to resubscribe all the changes which the standby hasn't received yet, and then we launch the replication. So there's one very important command here. So before we do anything, to resubscribe our standby for the subscriber, we need to create another slot. Next, for the master source not to get lost, we need to be able to use this slot, and this slot will be used using the PG logical slot get binary changes. Now let's look at particular cases. So initially we create a slot, we see the slot is created, but nobody's using it, it's inactive. Next, we add an entry to the source. We had this table, we added an entry. And we see that the replica 1 on the subscriber, so replication origin, and standby is similar both on the subscriber and on the standby. But if we look at the slot, we have not subscribed anybody to the slot. So the slot is in the past. What do? We use this function to get these changes. It's the logical slot use function using the protocol. It would be great simply to shift the slot, but since the function is not there, we have to start consuming. Then we see that the LSN is similar. It matches the replication. So what next? This is a case from real life. We emulate the delay of the subscriber standby. We edit the config and we kill the backend which uses the binary replication. Next, we make another entry. Let's say category 4. And we see the logical consumer receives this data, but the standby hasn't. Then this script is as follows. Let's say the subscriber has crashed. The master subscriber is blown up. We see that the standby of the subscriber is still lagging behind. And this is a very important point here. You need to eliminate the slot, the replication slot, which was there for the logical consumer, for the master. If you don't do this, then after you've promoted the subscriber, the subscriber standby, it will connect to that slot and will start getting changes from there. Which means there will be a big hole in the changes and he's not going to get it at all. So we see that the slot replica 1 is gone. We check the origin status for our consumer. We get LSN. We adjust our LSN in accordance with this LSN. We'll look and we see there's no data. Indeed, we're still lagging behind. The data is still on the replication source or in the slot. We promote the subscriber and we saw this errors start are running. So they're trying to get connected to the slot which we have deleted. But it's not there, so the system is starting to indicate errors. So we see the subscriber is still in the past, the data, the information is on the origin, but it's not on the standby. So we edit the subscription and we say that the system has to use the subscription was standby. It becomes active, starts reading data, the subscriber gets updates, and we see that this is on the master, but also on the subscriber. It is now available. So the slots, so it appears on the subscriber too. So another point I wanted to mention. There's one very particular case. A very important case there is that the subscriber of the logical replication cannot track the current position of the slot. The logical replication subscriber only knows the tracks that offer changes. But if our source is making the index or is being vacuumed, then vowels are generated. But the slot is being used, and you can see that it is being used, but nothing changes on the subscriber. So how do you use this standby slot? To do so, you need to look at the replication slots first in the table, right? So this is the position of our active user. Then we look at the active subscriber, we see the replication origin. We wait until the standby of this subscriber also shows the replication origin, which means that after that, the replication origin like this or bigger. So only after that can you start using this binary change, logical change that is, via SQL protocol, which we have for our standby mode for the case of any failure. So we have analyzed all our main cases. Now let's come up to the conclusions. So when we worked for SkyTools, we managed to do this. We also did it in Postgres 10, but there's a number of bushes, requests. You have seen for yourself that it's not so easy. it's very simple to get lost. Clearly, we're not talking about stock products. Well, first thing, you cannot create a logical slot on a standby. So which means that after you promote the source, you need to switch off the traffic, and basically you need to bear in mind that you need to create a slot, otherwise you'll get a hole after the promotion. Next, you cannot track the progress of the slot consumption on the logical consumer. Well, the way it was at Skytools, the third case, it would tell us that your subscriber does not match the source, and this is an error. There was this command rewind. Maybe this is why this simple verification to do for does not mismatch between the source and the subscriber. They have various positions because the subscriber does not have this data. Another point, we want replication advance to shift the slot on this source, not just use them by the SQL protocol. Another important point, replication origin is not transactional. As a result, we need to stop the working logical consumer to remember this LSN and to start making dump. Furthermore, PGDump does not dump the list of tables which match this replication source or the replication origin. As a result, you need to do the dump without the subscription. You need to create it manually, you need to identify what replication origin matches this, and you need to do this manually. One more thing. We also use this gimmicks at Avito, the tracking. If you need to do the tracking using the Postgres 10 logical replication, then you either have to write a special table for event tracking, or you need to use the function for recording while messages, and then you need to consume these messages somehow. And log table. Well, this is you do this by design. The replication goes via val, so you'll not be able to send logic tables to logical replication. Several more points about logical replication. Very interesting. This is a very interesting point in the documentation. When you want to use the same instances as source of logical replication, if you want to create the subscriber on the same transaction, so this is not possible. You need to create a slot separately and to create a subscription separately. But we thought about that was quite an interesting case, and we made the subscriber and the source on the same database. And then we only subscribe to updates, and we update just one line. As a result, we receive this event loop where we can insert a trigger, and we can use the trigger for anything. The sky is the limit for your fantasy. For instance, you need to distribute a transaction, you need to change 10,000 records. Or you can simply store these 10,000 records on the side, and then you process them on the event loop in the free time or in a certain sequence. Another interesting point. We at Avito saw machines which were overutilized on the disk space. And when val is an OS cache, and then we see that standby is lagging behind. When it does lag behind, the vals are generated very quickly. The command archive has no time to read these vals. And then Sergey wrote a very interesting script, which simply took the latest vals and archived them. And the command archive looked at them and saw that if they were there, so nothing had to be done. So we were able to overcome that failure. In the case of logical replication, you need to probably reinitialize the source, so you should bear this in mind too. Actually, about standby lagging behind, we would like to discuss it tomorrow during the quick reports. So, to conclude, I would like to say that if you're already using logical replication, or if you intend to start using it, then I would highly recommend to you to have another look at these slides and to transform them into scripts so that when you have a failure, you will be able to restore everything quickly. I hope that after looking at these slides and after looking at all these interesting words and symbols, characters, you will be able to think about it more and to look it up in the documentation to understand what it all means. Because if you want to get it straight after the system crashes, then our slides will be quite useful. But if something happens, please don't hesitate to write to us. Stas, Sergey, Konstantin, so thank you very much. Yeah, PG code. Yeah, please write to us about PG code. We'll tell you everything we know. Guys, your questions now. And please say your name so that I can note it, so that I can appraise your question at the end. Evgeny Zhukov. Do you write your undo blog in relation? So, do we write the undo log in the relation? We create a table, and in that table, and we use the trigger to record all the changes in that table. Have you measured the right modification? To what extent is it stronger? You have, let's say, you have so many bits on the master, and then you will be. You can make unlog it on the replica. Another important point. Right, you write a lot of backends on this source, but you play just one backend. So the backend has to be very quick. Most of our logical replicas are all unlogged. So we reserve them in pairs, but unlog it is very dangerous one, because if you switch it off for some reason, then all your data will turn into a pumpkin after midnight. Let's say you generate 10, 20, 30 backend on the master, but they're used in patches. The current logical replication consumes it in transaction, but we see with the amplification not on the basis of the place. Because we don't replicate the entire cluster; we only replicate particular parts. The size of database cannot exceed a certain size, but the amplification is done on the CPU based. We did unlogged, so our unlog is unlogged. You don't need to unlog it; you need to show it to the machine, because we restore them from standby. But even if you do this, you don't need the unlog. So we decided that you can make undo. And then you simply go by the CPU and by patch, and everything's fine. But with Postgres 10, you need to see how it all works with your load. The scripts are ready. You can give it a try. Up to what number of transactions the system will be able to work for you. My name is Artyom. My question is about the Landis Sky tools. Why that product, not PG Logic? Because we also use this replication. But we were thinking about PG Logical. Well, PG Logical is the same. But look, this demo showed you that it is not so easy to do these things, which had to be done according to a manual in SkyTools. And we're using SkyTools ever since Skype told about it. I mean, this technology was used even before we worked for Avito. It was very well known, very well tested. All the bugs were identified, corrected. So it was a very good, very clear solution that worked. And they had very interesting things like batching there. we mentioned them. And there was a number of other features that were quite handy, and everything went fine.
The question was, the second quadrant, the author of PG Logic, positions it as a much faster tool of logical replication. But I'm telling you that there is batching and there is not batching. So there can't be totally better or worse things. We need balance. And without this research about the 10, how logically it works. So we applied for participating in Canadian Postgres conference, and there are questions here. As it was not controlled in the schemas set when we launch play and masters, we need to have additional table. So we need to add something else into scripts. And all the questions that turn up, because you cannot easily rewind this log. So we would like to pose this question to a wider community. And when we used the PGQ before that, we did not have questions of this kind. But who supports PGQ? I believe only Avito. I will ask a separate question about PGQ, but I'm talking about PGQ. Because what is at the base of ScapeQ Plus is PGQ. And it is logical and it is nice and it is all based on tables. From Avito. I did not really understand one thing with the undo log. What happens with the data that we cancelled? What will happen with them? So it depends on business logic. If the data are critical, they are most likely to be registered in other bases, and we will be able to recover them from them. And we don't have synchronized replication at high-load nodes where the data are not critical. And when a master crashes, anyhow, these data are lost. So we need to have all other nodes in consistent condition. Konstantin said that it is similar to audit log. It is practically the same thing. There are some particularities and why it cannot work at all. There is no concurrency, and the stream of playing logical replication structures everything in one string, and the entry and undo goes along that string of implementation, and you store in undo log what has disappeared from source, and according to your business logic you can decide what to do with this data. It does not disappear, it is all stored in undo, and when you replay it you have all these entries, and then you just think what to do with it. And where did you lose it? Undo is applied, and they are stored, because undo is not at the source but at the receiver side, as we rewind the receiver.
Очень интересный. Давайте похлопаем ребятам. Спасибо за интересные вопросы.